Hello student. Today we will discuss some examples in which we will investigate the continuity of function of two variables. So the first example is fx is equal to fxy is equal to x cube plus y cube upon x minus y. X is not equal to y and its value is equal to 0 when x is equal to y. So here check the continuity of fxy at point 0, 0. So solution. So we know that a function is said to be continuous at a point a comma b if the limit of function, or we can say the simultaneous limit of function, exists at point a comma b and equal to value of function at that point, that is f 0, 0. So we have to prove this one. So for this, first of all, we check is simultaneous limit of fxy exist at the origin. For that, we take a path along x-axis passing through the origin. The origin. Say the path is y is equal to 0. Then we will check is limit when y is equal to 0, then limit xy tends to 0, 0, fxy is equal to limit, in place of y we will use 0, x tends to 0, in place of y we will use 0, then this function become x cube upon x, that is limit x tends to 0, x is square, and it gives us value 0. So along x-axis the limit of function is 0. Along path y-axis, that is x is equal to 0, the limit, put x is equal to 0, xy tends to 0, 0, fxy is equal to limit, take y tends to 0, in place of x we will use 0, so it become y cube upon minus y. So it is limit y tends to 0 y square, and again it gives us value 0. So along x-axis and along y-axis the limit of function are same. If we take an arbitrary path, suppose along path y is equal to x, then we can check that the limit xy tends to 0 f of xy is equal to limit xy tends to 0 0, f of xy is x cube plus y cube upon x minus y. And if we put limit y barabar x, then it become limit x tends to 0 in place of y tends to 0, in place of y we will use x cube and x minus x. Since x minus x is 0, so it become infinity. That means we cannot determine does not exist or does not exist or not finite. Not finite. Since the limit of function fxy along different paths passing through origin is different, so the simultaneous limit of fxy at origin does not exist. As in the last semester I taught you that we can also check the continuity of function by using the sequence or by using the sequential criteria. In case of single variable, we know that a function is continuous if a function fx is continuous if any sequence xn converges to point A, then its image under mapping f is converges to f of A, then we say f is continuous. Same concept is applied in case of function of two or more variables. Here we see that this is our origin. When we move to